Okay, so this video is going to go over atomic structure, what it means for things to be charged, and then finally the difference between conductors and insulators. So first, let's come back to this familiar simulation. I told you all you would get sick of it by the end of our unit. Maybe you are by now, but it's really important. Hopefully we remember that our protons, when we're constructing an atom, go inside the nucleus in the middle of every atom, as well as our neutrons. Okay? Our protons are all positively charged, our neutrons are neutral, and our electrons, our negatively charged electrons, all go on the outside of the atom. And I remember a lot of people bringing up valence, that term valence electrons, which we remember from chemistry, as meaning the electrons in this sort of outermost energy level surrounding our atom. And the reason that we keep coming back to this is because this microscopic structure of all matter, right, the atom, sort of our basic building block for matter, has to do with how things behave when they're charged, how we see really huge things in the macroscopic world that we can see behave. Our protons stuck in the nucleus never move throughout a material. They'll move however this full atom moves, but they're not going to jump outside of this atom and go into another nucleus, not without an insane amount of energy that will never just sort of appear without some huge input and some huge effort on our part. So the protons stay inside this really stable nucleus. Our electrons, on the other hand, are out here, and they pretty easily will jump over to another atom, or we could even see electrons from other atoms coming and bouncing into this atom pretty easily, right? They're not bound inside this really stable nucleus. They're just floating on the outside, drawn slightly into this positive center because we know our opposites attract, but it would be pretty easy for another atom to draw any of these electrons away, or for this atom to draw other electrons away and into its orbit. So that's sort of part one here. And I just want to make sure that I highlight where we've done this before, where we've sort of seen this concept, because this is hopefully not a new concept for us. This is knowledge that you all have been building in class over the past month. So we have this explanation that I really like that I want to highlight here. And this was an answer to the question, why do electrons get transferred? Why not protons, basically? And this answer says electrons get transferred when two materials are rubbed against each other because electrons are found on the outside of the nucleus and are weakly bound to the atom, which makes them easier to move, while protons do not move because they are found inside the nucleus and cannot move. That's exactly it. That much more eloquently and succinctly puts what I've been saying for the past 2 minutes about the importance of that atomic structure in analyzing like static electric behavior. Right? Our protons don't move, they're inside this nucleus. Our electrons do because they're outside the nucleus. And in terms of what it means for things to be charged, so the other reason that we looked at this simulation was to think about what it really means for things to be charged. So we know that our electrons can move and our protons can't, but we don't really know, like, not without some kind of thought or some kind of effort, what it really means for this to be negative. And I want to highlight more good answers that you all have given so far. And this was in our work from class that was called Charge Behaviors. What I had just highlighted was back in Droplets and Electrostatics from, I think, week 2. This is from Charge Behaviors. And these are some really good answers to the questions. Do positive ions have only protons? And the correct claim is no, right? Positive ions just have more protons than electrons. And negative ions, on the other hand, don't only have electrons. Negative ions just have more electrons than protons. So it's really about an imbalance between our electrons and protons that causes things to be charged. So if we come back over to this atomic simulation, you'll notice that it says negative ion right now. And you might be thinking, why is that? We still have some of our protons there in the middle, and we know that protons are positive. How can this still be a negative ion? That's because, like that explanation just showed us, we have more electrons than we do protons there. We have 6 electrons, all negative, because electrons are always negative, and only 3 protons, and our protons we know are positive. So we have 3 more electrons than protons, and that's why we can see that this net charge is -3. And you'll notice if I add electrons there, now this gets even more negative. Now we're at a net charge of -4, and if I add more, now we're at a -5 net charge because we have 5 more of these electrons than we do protons. So that's what it means for something to be negative. It's also important to remember before we talk about insulators and conductors how things become positive or negative. So we know that this would be positive if we had more protons than electrons, based on that explanation from before. Something's positive if it has more protons than electrons. But things don't usually become positive by gaining protons, again, because our protons are pretty much stuck inside of this atom. Protons from another atom are not going to leave their nucleus, which is really stable, to come join this nucleus, which is also pretty stable. The way that things become positive is we lose electrons. So you'll notice as I take these electrons away, our net charge gets less and less negative. So we're still a negative ion, but now we're negative 3. Take away more electrons, now we're negative 2. Now we're at a charge of negative 1. And eventually, if I take away enough electrons, now we're neutral. And a neutral atom is not one that has nothing inside it. It's one that has an equal number of protons and electrons. And if I remove one more electron, now our charge becomes positive. And in fact, it's positive 1 more specifically because we have one more proton than an electron. So that's really what it means for something to be charged, is that we have some imbalance between our positive protons and our negative electrons in an atom or throughout a material. Now, the last piece that we want to think about for our materials is how do our electrons behave differently depending on what material we're looking at, right? So we know protons pretty much never move, but we looked in a simulation that looks like this we looked at and tried to think about how electrons behave differently in a balloon, which I called an insulator here. That's the term that you would see like in a textbook. And those two metal rods in that simulation, and those are our conductors. And I think this observation is really clear and concise. The electrons in the balloon are still and not moving, while the electrons in those metal bars or rods are constantly moving. And from that, we generalized our insulator and conductor terms. But I want to take a second to show exactly what this explanation is really sort of getting at. So in this simulation, if I come back over here, you'll notice that our balloon has electrons in there, right? All of those little blue dots are electrons, but they're not moving at all. And if we compare that to how the electrons in these two metal rods are behaving, right? They're going nuts. They're moving around all the time. Even just this one electron in this positively charged rod will move around a lot, especially if I move the balloon. But the electrons inside of this balloon don't move around at all. This is our insulator, where electrons do not move very freely. And these are conductors, where our electrons do move freely and in fact will move around a lot depending on what else is around it, depending on what other charged objects are nearby. One other important thing to note here, you'll notice that our protons are still not moving, even though our electrons are. Remember, our protons are stuck inside the nucleus, and they stay pretty much still. Our electrons, though, they're on the outside of the nucleus. They can move around and bounce around between atoms throughout this. So even though the atoms of these metal rods are not moving, the full atoms are not moving, signaled by these protons, the positive nuclei of our atoms, the electrons can bounce back and forth very, very easily. So that all is to say that we sort of developed in class those two definitions for our insulators and our conductors, and I think this person's work sums that up really well. An insulator is some material in which electrons do not move freely. And a conductor is one in which materials do allow that really free flow of charge in one or more directions. And usually, pretty much always, we'll say always for now, that charge is in the form of electron flow. So those are, again, our sort of three earliest big concepts that we talked about in class, about the structure of atoms, about what it means for things to be charged as an imbalance between protons and electrons, and then finally that difference between insulators and conductors that you all have been building up in your groups in your breakout rooms.